The weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois Urbana-Champaign and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
I'm your host, Trent Ford, state climatologist with the Prairie Research Institute. Mosquitoes are a common sight in the summer, but they're more than just a nuisance. As the climate warms, mosquito populations are increasing across the world. According to the Centers of Disease Control and Prevention, rising temperatures can increase hot, humid days in the Midwest, which is a great environment for mosquitoes to thrive. And some species carry diseases that can pose risks to public health. Illinois is home to 60 species of mosquitoes, and about a dozen of them can transmit diseases. Joining us to talk about mosquitoes in Illinois and how climate change affects them is Dr. Chris Stone, Associate Research Scientist and Medical Entomologist at the Illinois State Natural History Survey. Welcome, Chris.
Hi, Trent. Glad to be here.
So you work with the Illinois Department of Public Health to track mosquitoes. Can you describe a little bit of how that surveillance works in Illinois and what you and your team look for and are doing every summer?
Sure, can do. So in Illinois, there's most of the mosquito surveillance is really focused on West Nile and is done by local health districts or where they have them, mosquito control districts. And they're really focused on the species that are involved in transmitting West Nile. They would go out, set traps, ID them, test them, and use that information to guide their control decisions. What we've been doing for about 5 years now with the Illinois Department of Public Health is trying to add to that, trying to supplement that, and both look for a broader set of mosquitoes that are not typically focused on when people are just looking at West Nile. So we're really trying to see how has mosquito diversity in the state changed over the past decades. That was really due an update. And then what are some of the potentially emerging or neglected, not really focused on viruses transmitted by arthropods and mosquitoes. So those are kind of outside of the scope or the capacity of a lot of these local health districts to test for, to look for themselves. And that's what we've been trying to focus on.
So thinking about weather and climate, what are the weather factors that determine what kind of mosquitoes can thrive in what regions?
Yeah, right. So if we think about what makes sort of a suitable habitat for a mosquito, it's a mix of different things. A really big thing is sort of the coldness and the harshness of the winter. So a lot of species aren't very good at overwintering if it gets too cold. The mosquitoes we have here will tend to be able to go into a diapause and kind of hibernate and get through the cold that way. So yeah, the temperature in the winter is a really a big one in terms of ranges and why you see certain mosquito species where you see them. And then, of course, things like, how hot does the summer get, or how quickly does it warm up in the spring? Rainfall patterns are really important because it drives so much of the mosquito ecology. So yeah, combination of those factors.
Yeah, and when it comes to rainfall, I know a lot of folks think, okay, it's been wet outside. That is maybe there's some flooding. It's naturally going to be good for mosquitoes, or maybe in a human's perspective, bad because of mosquitoes. Is that necessarily the case?
So it really depends on the species or the groups of mosquitoes and on their particular ecology. So for some mosquitoes, definitely. So we often think of them as more nuisance mosquitoes, sort of the floodwater mosquitoes. And what they'll do is they lay their eggs on soil that they think or have been sort of programmed in a way to think that those areas might flood at some point. And the eggs can be there for months or longer. And when there's a big rain event and those areas flood, that's when you get this massive hatching of mosquito eggs, and then really large swarms of mosquitoes of those species. For other mosquitoes, so if you think about the species that transmit West Nile, so these are the house mosquito, Culex species, particularly in urban areas where they might make use of sort of man-made structures like catch basins, for instance. There, we've sort of seen the opposite. So in that case, heavy rainfall can actually kind of flush them out of those habitats, and it's been linked to high mortality in mosquito larvae. So kind of the opposite effect. And actually, drought conditions have been tied to increases in the mosquito population. And that's because those species in particular really like nutrient-dense, sort of this thick soup. So once water's been present and it's evaporated a bit and really gotten potent and nutrient-dense, that's when those mosquitoes are the happiest.
So thinking about all of that and, temperature change, the temperature of winter especially, but also precipitation variability, this is a big question, but I'm going to ask it to you anyway. How is climate change affecting Illinois mosquito populations, or how do you expect it to into the future?
That is a big question. And one of the challenges always is really tying some of the changes that we're seeing to climate change. So if we think about mosquitoes in general, there are some really good examples where people have been able to do that. I'm thinking of one study where they looked at malaria mosquitoes in Africa and used this 100-year data set and really were able to show that with increasing temperatures, these mosquitoes were now occurring at higher altitudes because that had become warm enough for them to thrive. And also in that case, moving further southward, so towards the pole. So there are some really compelling examples where people have been able to show that. A lot of other evidence is more model-based, sort of taking what we know from how mosquitoes respond to temperature in the lab and using that to predict what might happen in nature. So the big expectation, I think, for which we have the best evidence is that you would expect sort of the ranges of different species to shift. And we are seeing some of that. So when we go out and like I said, we are looking for this diversity of mosquitoes. We have, for instance, detected a species that was considered as a southeastern mosquito. That's Culex nigripalpus. And we've been picking that up in southern Illinois. So that's an example of something that does seem to have really moved further northward, possibly due to climate change, but proving that will be more difficult. Yeah. And then other species that were already present, but we are seeing them further north in the state than we had before. So that would be, I think, maybe the most obvious case where you would expect the ranges of these species to shift.
And are those species, the ones you just mentioned, are they also West Nile carrying or otherwise disease vectors?
Yeah, potentially. So the one species I just mentioned, the Culex nigripalpus in the southeast, it has been connected to West Nile transmission as well as Eastern equine encephalitis transmission. I wouldn't be super concerned in Illinois because it still seems to be very rare. So it probably won't change too much and not be nearly as important as the mosquitoes we have already.
Yeah. If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois, Urbana-Champaign. I'm Trent Ford, state climatologist with the Prairie Research Institute, and today we're talking about how changing climate and weather affects mosquitoes in Illinois with Dr. Chris Stone, who's associate research scientist and medical entomologist at the Illinois Natural History Survey. So I just said we're talking about mosquitoes. Now let's temporarily shift to their nasty, I can't call them cousin because technically I guess they're arachnids, right? I know a little bit about bugs. Let's talk about ticks. Obviously, ticks are a problem. I don't think there's anybody who's been in Illinois for more than a minute who doesn't understand that. Do we have the same kind of behavior with ticks as we do with mosquitoes, especially with winter warming and expansion? I mean, how can we summarize the state of our knowledge about climate change in Illinois and the effect on ticks?
That's a great question. Yeah. So one I think interesting difference when you compare ticks and mosquitoes is ticks have this much longer lifespan. The life cycle can be 2 or 3 years. A lot of that time they actually spend in the soil or in the topsoil, kind of buffered. So a lot of these things like more variation or more, either more or less frequent rainfall events or these larger precipitation events, that they're probably fairly buffered against that sort of a change. But over a longer period, if you look over decades, you would still expect that if it's getting warmer, if the winters are getting milder, that should maybe speed up their life cycle a little bit or reduce their mortality over that, so that should translate into a greater population increase in those species too. One example I can point to, a study we did with colleagues in the Department of Entomology a few years ago, looking at the Gulf Coast tick. So this is another species that was traditionally associated with the southeastern United States. We've been picking up in southern Illinois in particular, a little bit in central Illinois, even in the Chicago area. And we did a habitat suitability modeling study on that, and the most important factor there, sort of determining whether the species is sort of likely to be able to establish somewhere, was the coldest temperature in the winter. So that does suggest to me that, you know, if that is changing, if that is increasing, that you would expect that species would be able to expand its range further northward. There's some really good examples too. If you look further north, like in Canada, there's been some, I think, compelling evidence that the black-legged tick, the Lyme disease vector, that's been spreading further north, probably related to climate change as well.
So switch over to diseases. Real quick, this transition here, comparison between mosquitoes and ticks. I think I've heard before that obviously both can be vectors for diseases, but ticks, the types of diseases that we associate with ticks tend to be a bit more prevalent in ticks than mosquitoes carrying diseases. Is that true, or am I characterizing that properly?
I think so. Yeah. So, the clearest example there would be Borrelia burgdorferi, so the bacteria that causes Lyme disease in humans.
Yeah.
So when we look at black-legged ticks, the adults of that species, when we've collected and then tested those for that bacteria, we find about 40% of them positive. So that's
40. Wow.
A pretty high level. And then for some of these other diseases, it's quite a bit lower, maybe between 1 to 5%. But compared to mosquitoes, that's still quite high. Sort of in the peak of summer, you might, you could get to that 1 to 5% in mosquitoes potentially, but it can be much lower than that as well.
Yeah.
So there's a big difference there. Tick-borne diseases are, of course, a real, increasing problem, becoming much more prevalent, and more awareness, luckily, about that as well. Particularly Lyme disease, and then
and kind of moving to mosquitoes again. You mentioned West Nile. Are there other types of diseases that your team is concerned about or studying here in Illinois? And then kind of expanding it out globally, we still hear this idea that or maybe it's not an idea, maybe it's just a fact that the mosquito is still the most dangerous animal in the world. How does global climate change bode for mosquito and mosquito-borne disease globally?
Right. Yeah. The first part, sort of some of the local diseases that we've been looking at outside of West Nile. One of these, and in Illinois, we used to have a reasonable number of cases of those each year, and something called La Crosse encephalitis virus, which tends to occur or at least the cases tend to occur in children, and can lead to neurological damage and be quite severe. So in the early 2000s, we would still see at least some cases in Illinois each year, and that seems to have declined or maybe even disappeared. So one of the big questions for us was, are we still finding this in mosquito populations? Is this just people aren't thinking about it because West Nile is taking up all the attention in a way? And we have picked that up in very few occasions, but it does not seem to be very prevalent. So that might reflect some kind of ecological change where this really has declined, perhaps due to control measures by public health districts targeting West Nile, or cleaning up of tires in the environment, or things like that. It could be that this has really declined. There are some other viruses. I mentioned Eastern equine encephalitis already. We've had human cases of that in quite a few of the states surrounding Illinois, but not in Illinois itself. And a few years ago, we did detect that the mosquito that transmits this virus, the primary vector of it, was present right in the greater Chicago area. So that at least tells us the potential for that virus to be transmitted here is here. luckily, we haven't seen any human cases yet, but knowing that it's here, I think, is really helpful and important in case you do need to respond to a case.
Yeah, we'll get you off guard.
And then another virus we've been really focused on the past 2 or 3 years is something called Jamestown Canyon virus, which is somewhat related to La Crosse that I mentioned earlier. And this one I find really interesting because it's a very different kind of system. So this is white-tailed deer are the host of this. So the mosquitoes that are involved in it are completely different from your West Nile virus mosquitoes. These are ones that tend to feed on deer and mammals. A lot of those are kind of early season species that develop in woodland or vernal pools. And it's quite a diverse set of mosquitoes potentially that can be involved in that. And that's something that tends to not be looked at all by the public health system. So we found a good bit of this virus. We know it's also present from other studies in deer in the state. But again, so far there's only been a very small number of human cases, and those are possibly acquired out of state. So again, there's this idea: is this a virus that's just increasing, and we might see more of it in the future, or is this just such a rare virus that it's present, but maybe not of immediate public health concern?
Yeah. If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Trent Ford, state climatologist with the Prairie Research Institute. And today we're talking with Dr. Chris Stone, associate research scientist and medical entomologist at the Illinois Natural History Survey. And then thinking about this globally is, so our prognosis maybe here in Illinois is more attention, maybe more prevalent disease spread by mosquitoes or ticks, or at least the potential for that. Is that the case in most global regions as well? We're seeing this?
Right. And I guess we also have the potential for these exotic viruses to be introduced into the state. And but yeah, if you look globally, one of I think the interesting interactions between temperature and mosquitoes or mosquito-borne diseases is that we always tend to think of increasing temperatures leading to increased numbers of mosquitoes and increased transmission of these different pathogens. But it does seem to come to a point where if it gets hotter than that, maybe once you get into the 90 degrees Fahrenheit or that range, it can get too hot for the mosquitoes as well, and they start suffering, and their survival rates start to plummet. And so it often is kind of this nonlinear effect. And so what people have predicted, at least, is that, for instance, in parts of Africa where you have a lot of malaria right now, that those areas might see a bit of a reduction, and you might see more of a shift towards more subtropical or temperate areas even. So it really depends on where you are. Certainly if you look at dengue is maybe one of the other really big mosquito-borne viruses of concern, and that has been increasing drastically over the past few decades, and you'd certainly expect that could continue, and that you might see more of that in subtropical areas too.
Okay. It's interesting then, because every time we get a really cold snap in the wintertime, first thing people will tell you is like, oh, it's killing the mosquitoes at least. And so if we have a heat wave like what we're experiencing here in early July, could we say, oh, it's 95 and it's super humid, but maybe it's killing the mosquitoes, or they can get away from that?
Well, they'll maybe if it continues for long enough, but they are quite good at finding these sort of microhabitats and finding shelter, and
they're also good at finding me, unfortunately. This feels like one of the segments that I give, where I just talk about terrible things like drought, and I know you find mosquitoes interesting. That's fun and everything, but we can maybe end a little bit on a high note by talking about ways that we can better surveil, study mosquitoes, and then also what individuals can do. So what are ways that you feel researchers like yourself, the role that they play moving forward in helping the good fight against mosquitoes?
Yeah. Yeah, so thinking, I'll start with surveillance then, and right, it does have some challenges, and particularly thinking about mosquitoes, just once you've collected all those thousands and thousands of them from the field, going through and identifying each of them to species under a microscope by someone who's trained to do that. It's a challenge. It takes quite a lot of time to do that. So there's been a lot of interest in trying to see if there's ways you could improve on that or make it easier through maybe development of molecular methods, but that has its own challenges, or maybe using artificial intelligence in some way. So there's a lot of interest in either using, say, neural networks to look at images and seeing if you could identify something to species just based on a picture of it, or some other fun approaches have been to look at the wing beat frequency, because each mosquito species has a slightly different size and wing morphology or wing shape, and they tend to have a very particular frequency that is associated with that species, but it's a bell curve, right? So if you're something might be at 300 hertz, and a different species might be a little bit higher than that. So there's a lot of interest in seeing if you could use that, and then using microphones to pick that up, and a database and some AI to match those. So yeah, definitely potential to keep working on that. I think that's really interesting. I also do think we're always going to want and need just taxonomic experts, and have those human's eyes look at species, just to be able to see if you're picking up something unexpected that shouldn't be in a certain region. And I think the accuracy often can still be, I'd still trust that a little bit more. So I think actually just continuing to train new people, students, or a new generation in taxonomy, in learning how to identify that the mosquitoes or ticks, I think is really important, and something we should not forget outside of those other advances. One other thing that residents or non-scientists could help out with this surveillance is another big challenge is actually getting people to these different locations, setting up the traps, doing the collections. So there's also quite a bit of interest, and we've been developing some of that too, is to get citizens or residents of the state involved in these collections. So one example of that is we're calling it our Mosquito Ambassadors program, where people can order a little collection kit, which is basically just a cup and a little tea bag, and instructions on how to use that to make your own grass infusion, your water that will be attractive for mosquitoes who want to lay eggs. And then people could put that out in their backyard. If they collect mosquito eggs, I think it's a fun experiment really for particularly for children to see.
Yeah.
And they can send that to our lab, and then we'll hatch those eggs, and that will give us an ability to sort of track like the spread of, for instance, the Asian tiger mosquito more easily without having to be everywhere ourselves, and potentially do other things with those samples as well, like look for insecticide resistance genes and things like that. So involving people in that way to help us strengthen our surveillance system is, I think, really promising too.
How can people are out and about, especially during the summertime when we have nice weather, just telling people, well, don't go outside. That's not usual. How can people protect themselves from mosquitoes when they are outside doing things?
Yeah, so it is a big issue, and I'm reminded of a study a few years ago where people looked at the impact of Asian tiger mosquitoes in people's backyards, and it did suggest that people are spending less time outdoors, or maybe less willing to send their kids to play outdoors or in their backyard, because the bites can just be so obnoxious. So it's a big issue, and it could potentially affect health and well-being, and right. So for mosquitoes, I think the big one is, at least around the house, trying to eliminate mosquito breeding sites. So they have this aquatic larval stage, so they really rely on standing water. And yeah, particularly these Asian tiger mosquitoes and a few others, but that one is really notorious for it. Can really, the smallest container, the smallest amount of standing water can be enough for those to complete their life cycle. So trying to eliminate, containers or cups or things that, tarps or anything that might have standing water on it, either just get rid of it Or if that's not possible, at least, twice a week or so, make sure you tip it over and get rid of the water, just to not give the mosquitoes the chance to develop there. Gutters, if you have a blocked gutter that has standing water, that can be a challenging one, but that can be a good mosquito habitat. There's some research also done locally a few years ago that found that rain barrels are quite often host to these mosquitoes as well. They tend to find a way into those things, or right. So that can be a big one, but of course there's only so much you can do in your own backyard. You're sort of reliant on what's the environment in your neighborhood and neighbors as well. So using either wearing long sleeves and long trousers, but that's also not always appealing. So insect repellent is still very effective though. So DEET based, or there's some other effective ones as well. So looking for an EPA registered mosquito repellent would be a really helpful thing to do. Yeah, so I think you mentioned it earlier that I'm fascinated by these creatures. I started, in part studying malaria because of the public health concern, and I think one of the reasons I've probably stuck with this is because their behavior, their ecology, their physiology is also just fascinating. So I'd love for people to know more about those aspects too, and I think it helps you have, not that you need to appreciate them because they are a nuisance and they're a public health threat, but it helps you understand maybe a little bit more about how you could modify your environment, how you could protect yourself. But they are really fascinating creatures too, and there's a tremendous diversity and some really cool mosquitoes as well.
Thanks, Chris, for joining us. It's been a pleasure.
Yeah, thanks so much.
So we've been talking with Dr. Chris Stone, Associate Research Scientist and Medical Entomologist at the Illinois Natural History Survey. I'm Trent Ford, the State Climatologist at the Prairie Research Institute. Thanks for joining us here on Weather Realness. Do you have a weather or climate question you want us to answer? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu.